हेलो एवरीवन। आज हम लोग सीखेंगे डॉट प्रोडक्ट और स्केलर प्रोडक्ट। सो लेट a vector and b vector be two non-zero vectors inclined at an angle theta. Then scalar dot product a dot b is defined as mod of a, that is magnitude of a vector, into mod of b vector into cosine of the angle between them. So if we say this is our a vector and this is our b vector and angle between them is theta. So a dot b would be mod a mod b cos theta, right? So from this we can see that there is no direction. So hence we can say that scalar product of two vectors is a scalar quantity, or dot product of two vectors is a scalar quantity. Okay, now see, if a vector or b vector or both is a zero vector, then theta is not defined, right? Either of them cannot be zero because zero vector has no direction. So in this case, their dot product a dot b is defined as scalar zero. Okay, so if a vector or b vector or both is a zero vector, both is a zero vector, then theta is not defined as zero vector has no direction. So in this case, the dot product a dot b is defined as the scalar zero, and another thing you have to remember is that if we let a vector is AB, okay, let us see this diagram first. This is your a vector, this is A, this is B, this is your M, let us say this is L line, this is P, this is Q. So let A is AB vector be a given vector and L be a given line, and let P and Q be the feet of perpendiculars drawn from A and B, okay, on the line L. Then PQ is defined as the projection of a vector on line L. So we can say PQ is defined as the projection of a vector on line L. Let AM is a perpendicular on BQ, then definitely we can say that AM is equals to PQ. And let theta be the angle between a vector and the line L. Okay, then angle BAM would be theta. So from this triangle AMB, we can say that cos theta is equals to base by hypotenuse, that is AM by AB, or AM is equals to PQ, so it would be PQ by AB. So you can say PQ is AB cos theta, AB cos theta, and AB is modulus of A. So you can say PQ is modulus of A vector into cosine of theta. Okay, so hence projection of A vector, projection of a vector A on a line L is modulus of A cos theta. Okay, where theta is the angle between that vector and the line L. And similarly we can say, let us see this diagram. If we have a vector, let's say this is OA, this is your AM, this is your theta. So if we assume OA vector to be a vector and L is a line passing through origin, then OM is the projection of a vector on the line L. Okay, so similarly we can say OM is OA cos of theta, that is modulus of A cos of theta. So by dot multiplication or dot product or scalar product, we can find the projection of a vector on another vector or another line. This is the geometrical interpretation of scalar product. Now, if we elaborate this concept for two vectors, let us say we have to see the geometrical interpretation of scalar product. Let us see this geometrical interpretation of scalar product. So let us draw a diagram first. This is your A vector, this is your B vector, this is your OB, this B vector, and draw a perpendicular line here and draw a perpendicular line from A on B vector. Let's say this is M point, this is your B vector, this is your A vector. So from this we can say projection of B vector on A vector is given by A dot B by modulus of A vector. प्रोजेक्शन ऑफ बी वेक्टर ऑन ए वेक्टर, जिसके ऊपर प्रोजेक्शन रहेगा वो वाला नीचे आएगा, उसके ऊपर डॉट प्रोडक्ट होगा ऑफ दैट टू वेक्टर. So if we write this as A vector by modulus of A vector dot B vector, this is unit vector, right? A vector by modulus of A, this is unit vector dot B vector. So we can think of this in this way, that projection of B on A, जिसके ऊपर प्रोजेक्शन निकालना है उसका यूनिट वेक्टर निकालना है, और जिसका निकाल रहे हो उसके साथ डॉट प्रोडक्ट कर देना है. ओके, so these two things are extremely important. And projection of A on B, so इसके साथ कंपेयर करके बोल दो तो सिमिलर होगा. A डॉट बी प्रोजेक्शन किसके ऊपर निकाल रहे हो, B, तो नीचे क्या आएगा B वेक्टर, और इसको भी तुम लिख सकते हो A वेक्टर डॉट B वेक्टर बाय मॉड्यूलस ऑफ B वेक्टर, दिस इज यूनिट वेक्टर, so A वेक्टर dot B cap. Thus the projection of A on B is a dot product of A with the unit vector along B vector, and the projection of B on A is the dot product of B vector with the unit vector along A. Okay, and this angle is theta. So next, moving forward, next topic is properties of scalar product. So if we see the properties, property number 1 is commutativity. So dot product obeys commutative law, that is A dot B is equals to B dot A. Property 2, distributivity of scalar product over vector addition. Okay, vector scalar product of a vector is distributive over vector addition. So if we say A vector dot B vector plus C vector, it would be A dot B plus A dot C. This is left, A is on the left side, so it is known as left distributivity. And if we say B plus C vector dot A vector, that is B dot A plus C dot A. A is on the right hand side, so this is right distributivity. Okay, now let us see property number 3. If property number 3 is if A dot B is 0, so when it is possible, when theta is 90 degree, cos 90 is 0, right? Mod A mod B cos theta, that is cos 90 So theta is 90 degree. That means two vectors are perpendicular. So A dot B 0 imply by A vector is perpendicular to B vector. Okay. Now from this we can conclude that unit vectors, that is, if we do I dot j, if we do j dot I, this should be 0 because I unit vector is along x axis, j is along y axis, x and y are perpendicular. Similarly, y and x are perpendicular. So their dot product should be 0. Similarly, j dot k or k dot j should be 0. Similarly, k dot I and I dot k should be 0. Now property number 4 is if A is any vector, then A dot A, similar dot product, the mod A mod B, so mod A into mod A, that is A square, into these are similar vectors, that means cos 0, angle is 0. So cos 0 is 1, so we can write A dot A as mod of A vector square. Okay. So similarly, from this property we can say I dot I is modulus of I cap square, that is 1 because it has the magnitude 1. J dot j, that is modulus of j square, that is 1, and k dot k, that is modulus of k square, that is 1. Now moving forward, property number 5. If m is a scalar, if m is a scalar and A and B be any two vectors, then we can say m a vector dot b vector, that should be taking m outside because it's a scalar quantity, m into a dot b, or we can say a dot m into b. Okay. Now property number 6. If m and n are scalars and a and b are two vectors, then m a vector dot n b vector, we can write it as mn a dot b, or we can associate mn with mn a vector dot b vector, or we can associate mn with b, so a vector dot mn b vector. Okay. So our next property is 7, which is for any two vectors a and b, a dot minus b vector is minus of a dot b vector, and we can say minus of a vector dot b vector. And if we have, is number 1, and if we have minus a vector dot b vector is a dot b. Actually, dot product gives us the flexibility to apply all the algebraic operations. Okay. So property number 8 is for any two vectors a and b, modulus of a plus b square, that should be modulus of a vector square plus modulus of b vector square plus twice a dot b. Similarly, for minus, we can write modulus of a vector minus b vector square, that should be modulus of a vector plus modulus of b vector square minus twice of a dot b. Similarly, a vector plus b vector dot a vector minus b vector is modulus of a vector square minus modulus of b vector square. Okay. Now, if we want to see scalar product in terms of components, so scalar product in terms of component, let us say our a vector is, in terms of component, is given a1 I cap plus a2 j cap plus a3 k cap, and b vector is given b1 I cap plus b2 j cap plus b3 k cap. Okay, then a dot b would be similar product is 1 in case of dot product, right? Because angle is 0. So I dot I would be 1, j dot j would be 1, and k dot k would be 1. And dissimilar product is 0. I dot j would be 0 because I is along x axis and j is along y axis. So angle is 90 degree. So cos 90 would be 0. So dissimilar product is 0. So we have to see only similar product. That means a1 into b2, a2 b1, a2 into b2, and a3 into b3. That's all we got. a1 b1 plus a2 b2 plus a3 b3. Okay. So you can remember in this manner, similar product is 1, and this similar product is 0 in case of dot product. Now, if you want to find out angle between two vectors using dot product, you can find out this angle between two vectors. See, we know a dot b is mod a mod b cos theta. So this implies cos theta is a dot b by mod a mod b. Okay, you can apply directly the dot product between two vectors to find out the angle between them. Now let us see the next topic, which is components of a vector along and perpendicular to vector. Okay, so let us see the diagram. Diagram is, we have a vector, we have b vector. This is our origin, this is b, and let us draw a perpendicular here. This is our perpendicular m. and angle between A vector and B vector is theta. Okay. So from triangle OBM, from this triangle OBM, we have OB vector is OM vector plus MB vector plus MB vector. If we OB vector is equals to OM vector plus MB vector. We have applied here the triangular law of addition. So OB vector is your B vector and it is OM vector plus MB vector. Okay. So we can say OM, this OM, and MB, this MB, are components of B along A vector and perpendicular to A. OM vector is the component of B along A vector and MB is the component of B perpendicular to A vector. Right? So we can say OM vector, which is along OA vector, is magnitude multiplied by direction. Okay. So we can say OM vector is OM is OB cos theta into A cap, or OM vector is modulus of OB is OB cos theta, that means is the modulus of B vector. So modulus of B cos theta into A cap. So we can say OM vector is modulus of B vector into cos theta is A dot B by mod A mod B into A cap. So it would be mod B cancels out. It would be A dot B by modulus of A multiplied by A cap. Now we can say OM vector is A dot B by modulus of A vector, and we know A cap is A vector by modulus of A. So this is A dot B by mod A into mod A, that is mod A square into A vector. Okay, this is a component of B along OA. And if we say, now see, our B vector is OM vector plus MB vector. Now we can say MB vector is B vector minus OM vector. So B vector minus A dot B by modulus of A square into A vector. So from this we have just found out the component of B perpendicular to A. Okay. So this is your component of B along A, and this is your component of B along A, this component, and this is a component of B perpendicular to A, this component. Okay, now let us see some question to understand the application of dot product. So our first question is, find A plus 3B vector dot 2A vector minus B vector if A vector is I cap plus j cap plus 2k cap and B vector is 3I cap plus 2j cap minus k cap. So let's find the solution. So we have been given with A vector and B vector. So first of all, find out A plus B. So A plus 3B, it would be A is I cap plus j cap plus 2k cap multiplied with plus 3 times of B, that is 3I cap plus 2j cap minus k cap. So it would be, if you add 9I cap plus I cap, that is 10I cap. Similarly 7j cap minus k cap. Now if you find out 2A vector minus B vector, that is twice of A vector is I cap plus j cap plus 2k cap minus B vector. B vector is 3I cap plus 2j minus k. If you find out, you will get 2I cap minus 3I cap, that is minus I cap, 2j cap minus 2j cap, so that would be 0 j cap. You can say minus 0 j cap, 4k cap plus k cap, you will get 5 plus 5 k cap. Okay, this will be plus 0 j cap. So they need dot product. So this implies A plus 3B dot 2A minus B. This would be 10I cap plus 7j cap minus k cap dot minus I cap plus 0j cap plus 5k cap. Similar product is 1. So these have to be 10 into minus 1, that is minus 10, 7 into 0, that is 0, and minus 1 into 5, that is minus 5. So answer is minus 15. Okay. Now let us see another question. Question number 2. Let A vector and B vector be two vectors of the same magnitude such that the angle between them is 60 degree, and A dot B is 8. Find modulus of A and modulus of B. Okay, so let's see the solution. It is given that A vector dot B vector is 8. So from this we can say mod A mod B, cos of angle is given 60 degree, is 8. Okay, and it is given that A and B be two vectors of the same magnitude. So magnitude is same. So it's given that mod of A vector is equals to mod of B vector. So from this we can say modulus of A square cos 60 is half, goes to 8. So from this modulus of A is 16, square root of 16 is 4. 4. That should be equals to modulus of B. That's all we have to find out. Okay. Now let us see our next question, that is question number 3. Question number 3 is, for any two vectors A and B, for any two vectors A and B, prove that modulus of A plus B square is mod of A square plus mod of B square. This imply by A and B are orthogonal. So let's see the solution of this question. See, we have given, we have to find out mod of A plus B square is given that mod of A square plus mod of B square. Do we know mod of A plus B square? This modulus of A square plus modulus of B square plus twice A dot B. That is equals to mod of A square plus mod of B square. So it will cancel out both the sides. So this implies twice A dot B is 0. This implies A dot B is 0. So that means A and B are orthogonal. Orthogonal means perpendicular. Okay. Now let us see our next question. If A vector plus B vector plus C vector is 0 vector, mod of A is given 3, mod of B is given 5, and mod of C is given 7. Find the angle between A and B vector. So let's see the solution. It's given that A plus B plus C is 0. So we can write it as A vector plus B vector is minus of C vector. So if we give mod on both the sides, so it would be mod of A plus B vector, that should be mod of minus C vector. Okay, and mod of minus C is C. And if we do square on both the sides, so it would be mod of A square plus mod of B square plus twice mod A mod B cos theta. That is modulus of C square. Mod of A is given 3, so it will be 9. Mod of B is 5, so it will be 25. And 3 into 5, 15, 15 into 30 cos theta. That should be C is 7, so 49. So from this, you will get cos theta is half. This implies theta is pi by 3. Okay. Now, let us see our next question. For any two vectors A and B, prove that mod of A plus B is less than equals to mod of A plus mod of B. Okay. This is known as triangle inequality. So let's see the solution. We know that mod of A plus B square is mod of A square plus mod of B square plus twice A dot B. Okay. And it is mod of A square plus mod of B square plus twice mod of A mod of B cos of angle theta. Okay. Now we know cos of theta is less than equals to 1 for all theta. So we can say twice mod of A mod of B cos theta should be less than equals to twice mod of A mod of B. We have multiplied both the sides twice mod A mod B. And if we add mod of A square plus mod of B square, will be less than equals to mod of A square plus mod of B square plus twice mod A mod B. Okay. So we can say that mod of we can say that mod of A plus B square is, because it is A dot B, right? This is A dot B, so we can say that this is mod of A plus B whole square. This is less than equals to mod of A plus mod of B square. So taking square root on both the sides, we will get mod of A plus mod of B is less than equals to mod of A plus B less than equals to mod of A plus mod of B. That's all we have to prove. Okay. Now let us see our next question. Our next question is the scalar product of the vector a vector I j k with a unit vector along the sum of the vectors b vector is 2I cap plus 4j cap minus 5k cap, and c vector has lambda I cap plus 2j cap plus 3k cap is equal to 1. Find the values of lambda. Find the values of lambda, and hence find the unit vector along b plus c. So let's see the solution. See, a vector is given as I vector plus j vector plus k vector, and b vector is given as 2I vector 2I cap plus 4j cap minus 5k cap. These are unit vectors. And c vector is given as lambda I cap plus 2j cap plus 3k cap. Okay, so first of all, let us find out b plus c vector. B plus c, that is 2I cap plus lambda I cap, that is 2 plus lambda I cap plus 6j cap minus 2k cap. Okay, the scalar product of the vector A with a unit vector along the sum of the vectors b and c. That's why we have found out b plus c. And we need a unit vector along b plus c, right, according to the question. So let r cap denote the unit vector along b plus c. So we can say unit vector along b plus c, that is that vector by modulus of that vector. This is unit vector, right? So b plus c vector is 2 plus lambda I cap plus 6 j cap minus 2k cap divided by modulus of this, that means root under of x square plus y square plus z square. So 2 plus lambda square plus 6 square plus minus 2 square. So this is 2 plus lambda I cap plus 6j cap minus 2k cap divided by square root of 2 plus lambda square plus 36 plus 4. It is 40. So let me write 40. Okay, and it is given in the question that unit vector scalar product with a vector gives 1. right? So according to the question, a vector is I cap j cap plus k cap dot product with unit vector along b plus c is r vector gives 1. This implies I cap plus j cap plus k cap dot product with r cap is this 2 plus lambda I cap plus 6 j cap minus 2 k cap by square root of 2 plus lambda square plus 40. This is 1. So similar product is 1, that is 1 into 2 plus lambda, 2 plus lambda, j dot j is 1, so 6 into 1 is 6, k dot k is 1, so minus 2. That should be root under of 2 plus lambda square plus 40. Okay, so you can say this would be 2 cancel out lambda plus 6, and if we do square on the both sides, it would be lambda plus 6 square is 2 plus lambda square plus 40. This would be lambda square plus 12 lambda plus 36, and this would be lambda square plus 4 plus 4 lambda. So lambda square will cancel out. Here we will have 12 lambda, here we will have 4 lambda. So we got 8 lambda, and here we got 36. Here we have 40, so plus 4, and here we will have 4, that is 8. So 8 lambda is equals to 8. This means lambda equals to 1. Okay, now put the values in r cap. So r cap would be 1 by 7, 3 I cap plus 6 j cap minus 2 k cap. Okay, that's how we have to solve this type of problem. Let's see another question. If with reference to a right-handed system of mutually perpendicular unit vectors I cap, j cap, k cap, we have alpha vector as 3 I cap minus j cap and beta vector as 2 I cap plus j cap minus 3 k cap. Express beta in the form of beta vector equals to beta 1 vector plus beta 2 vector, where beta 1 vector is parallel to alpha vector and beta 2 vector is perpendicular to alpha vector. So let's see the solution of this question. See, it is given that beta 1 is parallel to alpha vector. Beta 1 is parallel to alpha vector. So we can write beta 1 vector as some scalar lambda multiplied by alpha vector, right? Here lambda is a scalar. That's how we represent parallel vectors. Okay, and it is given that you have to represent beta vector as beta 1 vector plus beta 2 vector. Okay, so beta 2 vector would be beta vector minus beta 1 vector. That means beta vector minus lambda into alpha vector. And it is also given that beta 2 is perpendicular to A. So that means beta 2 dot alpha should give 0, right? So this implies beta 2 is beta minus lambda into alpha vector dot alpha vector is 0. Now if we multiply beta dot alpha minus lambda will come outside, it will be alpha dot alpha, that should be 0. So this implies lambda is beta dot alpha vector by alpha dot alpha. Now alpha and beta vector are given. Alpha vector is given as 3 I cap minus j cap, 3 I cap minus j cap, and beta vector is given as 2 I cap plus j cap minus 3 k cap. So what should be our beta dot alpha? Beta dot alpha, that is I dot I is 1, so 3 into 2, that would be 6. J dot j is 1, so 1 into minus 1, that is minus 1, and there is no k, so it would be 5. And what would be alpha dot alpha? Alpha dot alpha, that is 3I minus j dot 3I minus j. So I dot I, that is 3 into 3, that is 9, and minus 1 into minus 1, that is plus 1, that is 10. So let us put the values. Beta dot alpha is 5, alpha dot alpha is 10. So this is half. Now we know beta 1 vector is lambda into alpha vector. So it would be lambda is half and alpha vector is 3 I cap minus j cap. So it would be 3 by 2 I cap minus half j cap. Now what is beta 2 vector? Beta 2 vector is beta vector minus beta 1 vector. Okay. Now what is beta? Beta is 2 I cap plus j cap minus 3 k cap. 2 I cap plus j cap minus 3 k cap. And beta 1, just we have found out, is 3 by 2 I cap minus half j cap, right? So 2 I cap minus 3 by 2 j cap, 3 by 2 I cap, it will be 4 minus 3, that is half I cap, and plus j cap minus half j cap, minus plus half j cap, it would be plus 3 by 2 j cap, there is no k component, so it would be minus 3 k cap, right? So hence we have found out everything. Beta 1 is 3 by 2 I cap minus half j cap, and beta 2 is half I cap plus 3 by 2 j cap minus 3 k cap. Okay, so if you know the basics, you can solve this type of problem very easily. So let's see another question. Let's see another question. If a vector, b vector, c vector are three mutually perpendicular vectors, of equal magnitude, prove that a plus b plus c vector is equally inclined with vectors a, b and c vector. Also find the angle. Okay, so let's see the solution. See, a, b, c have equal magnitude. It is given. So let us say mod of a vector is equals to mod of b vector is equals to mod of c vector. That is lambda. Let us say. And it is given that a, b, c are mutually perpendicular vectors. That means a dot b, b dot c, c dot a all should be 0, right? And we know that modulus of x vector square, that is x dot x. So modulus of a plus b plus c square would be a plus b plus c dot a plus b plus c. Okay, now let us multiply this. It will be a dot a plus b dot b plus c dot c plus 2ab plus 2bc plus 2ca. A dot a is modulus of a square, b dot b is modulus of b square, and c dot c is modulus of c square. And a dot b, b dot c, c dot a all are 0. It is given, right? And all of the magnitudes are same. So we can say this is 3 lambda square. That is equals to modulus of a vector, b vector, c vector square. So mod of a plus b plus c should be square root of 3 into lambda. Now let a vector plus b vector plus c vector makes angles theta 1, theta 2, theta 3 with a vector, b vector and c vector. then cos theta 1 would be cos theta 1 with A, that is A dot B by mod A mod B. So A dot B, B is here A vector, B vector plus C vector divided by modulus of A into modulus of A plus B plus C. So if we multiply, it will be A dot A plus A dot B plus A dot C divided by modulus of A vector plus B vector plus C vector. Okay, so A dot B and A dot C, A dot B and A dot C are 0, right? So A dot A is modulus of A square. So we can say cos of theta 1 is modulus of A square divided by modulus of A into modulus of A vector, B vector, C vector. So 1 modulus of A is cancelled. So it would be modulus of A by modulus of A vector, B vector plus C vector. So modulus of A is lambda, modulus of A plus B plus C is root 3 lambda. So it would be 1 by root 3. Okay. So theta 1 would be cos inverse of 1 by root 3. Okay. So similarly, we can find out with other vectors. You have to do B dot this thing, you have to do C dot this thing. You will get the same result. You will get theta 2 as cos inverse 1 by root 3 and theta 3 as cos inverse 1 by root 3. So from this, we can see that theta 1 is equals to theta 2 equals to theta 3. So A plus B plus C is equally inclined with ABC. That's what we have to prove. So I think ये तुम लोगों को समझ में आया होगा. So लाइक करो, सब्सक्राइब करो और शेयर करो और कमेंट में बताओ तुम लोगों को कौन से चैप्टर का वीडियो चाहिए. थैंक यू एंड हैव अ गुड डे.